In this video, we're going to focus on finding the derivative of a function using the definition of the derivative, or the limit process. But before we do that, let's talk about how to find the derivative the easy way, and then we'll do some examples. We'll confirm it using limits. So let's say if you have x cubed, what is the derivative of x cubed? You can use the power rule. The derivative of a function x to the n is nx to the n minus 1. So it's going to be 3x squared. The derivative of x to the fourth is 4x cubed. X to the fifth, 5x to the fourth. So knowing that, go ahead and find the derivative for the following functions. So for x to the 7, it's 7x to the 6. X to the 8, 8x to the 7. And then for these two, it's 9x to the 8, and then 10x to the 9. Now let's say if you have a constant in front of it. What do you think the derivative of 4x to the fifth is equal to? So what you should do is differentiate x to the fifth. The derivative of x to the fifth is 5x to the fourth. And then you can multiply 4 and 5 and you'll get 20 x to the fourth power. Now what about this one? 7x to the 6. What is the derivative for that function? So let's differentiate x to the 6th power. This is going to be 6x to the 5th power times 7 is 42x to the 5th power. Now what about 8x cubed? So this is 8 times 3x squared. So the derivative is 24x squared. Now let's say if you want to find the derivative of 7x. The derivative of 7x is 7. 5x is 5. Negative 4x is negative 4. Pi x will be pi. Another way you could see it, if you want to differentiate 7x, this is the same as 7x to the first power. So if you differentiate x to the first power, this is going to be 7, 1x to the 0. Anything raised to the 0 power is equal to 1, so this is simply 7. Now what is the derivative of a constant like 6? The derivative of a constant is 0. So the derivative of negative 4 is 0. The derivative of e without the x is 0. And for pi without the x is 0. Now let's say if we want to find the derivative of x squared. What's the answer? Using the power rule, we know it's going to be 2x to the first power. But how can we use limits to get this answer? Here's the equation that you need. The derivative of a function is equal to the limit as h approaches 0, f of x plus h minus f of x divided by h. Now our next step is to find out what exactly is f of x plus h. To figure out what it is, you simply need to replace x with x plus h. So if f of x is x squared, f of x plus h is simply x plus h squared. And this part is simply the original function, x squared, divided by h. So now what can we do at this point? There's two ways you can solve it. You can FOIL x plus h squared, or you can factor using the difference of perfect squares. Let's use the FOIL method. On the contrary, let's save the FOIL method for another example. Let's use the difference of squared methods. For example, if you want to factor x squared minus 25, it's going to be x plus 5 times x minus 5. So, if we want to factor x plus h squared minus x squared, it's going to be x plus h plus x times x plus h minus x divided by h. So in the second one, notice that we have x minus x. We can cancel these two. So what we now have is the limit as h approaches 0, x plus h plus x times, the only thing that's left over here is simply positive h divided by h. So we can cancel these two. X plus x is equal to 2x. So we have 2x plus h, limit as h approaches 0. Now we can plug in 0. We can replace h with 0, so it's 2x plus 0, which is equal to 2x. So we have the answer. As we mentioned before, the derivative of x squared is 2x. So that's how you can prove it using the limit process. Now let's try another example. Let's say if f of x is equal to x squared plus 5x minus 7. What is the derivative of the function? Now we know that the derivative of x squared is 2x. We saw that in the last example. And the derivative of 5x is 5. So we need to get 2x plus 5 as our final answer. The derivative of a constant is 0. So now let's prove it using limits. So the limit as h approaches 0, f of x plus h minus f of x divided by h, this is equal to f prime of x. So we need to get 2x plus 5 as our final answer. Now in this particular problem, what is f of x plus h? So everywhere we see an x, we need to replace it with x plus h. So it's x plus h squared plus 5 times x plus h minus 7 and minus f of x, which is simply the original function. So that's going to be x squared plus 5x minus 7 divided by h. So we need to FOIL this expression. X plus h times x plus h. This is equal to x times x, which is x squared, and then x times h, which is xh, h times x, that's also xh, and then h times h is h squared. So we can combine these two. xh plus xh is 2xh. So therefore, x plus h squared is x squared plus 2xh plus h squared. Now let's distribute the 5. So it's going to be 5x plus 5h. Let's not forget the negative 7. And let's distribute the negative sign to every term that we see here. So it's going to be negative x squared minus 5x plus 7 divided by h. And we still have the limit. So on a test, if you have like a free response question, make sure you rewrite the limit expression until you replace h with 0. So now we can cancel x squared, and we can also cancel 5x, and we can get rid of the 7's. So now what we have left over is the limit as h approaches 0, 2xh plus h squared plus 5h, which is basically those three things, divided by h. Now our next step is to factor out h in the numerator, since that's the GCF. So if we remove h, it's going to be 2x plus h plus 5 divided by h. Now once we can get rid of the h on the bottom, then we can plug in 0 into the equation. So right now we have the limit as h approaches 0, 2x plus 5 plus h. So now let's substitute 0 into h. So it's going to be just 2x plus 5. And as we can see, these two answers, they match. Consider this problem. Let's say if f of x is x cubed. What is the derivative of the function? Now we know the derivative of x cubed is 3x squared. So use the limit to prove that the derivative is 3x squared. So f prime of x is going to be the limit as h approaches 0, f of x plus h minus f of x divided by h. So f of x plus h, that's going to be x plus h raised to the third power, and then minus x cubed divided by h. So should we FOIL it 3 times, or is there another way in which we can simplify this expression? It turns out that we could factor the expression. You can factor it using the difference of cubes equation. For example, a to the third minus b to the third is a minus b times a squared plus ab plus b squared. So in this case, a is going to be x plus h, b is going to be x. So to factor it, it's going to be the limit as h approaches 0, and then a minus b, or x plus h, which is a, and then minus b, which is x, times a squared, which is x plus h squared, plus ab, which is x plus h times x, and then plus b squared, which is plus x squared, all divided by h. So x and negative x will cancel. So now what we have left over is the limit as h approaches 0, h times everything else, x plus h squared plus x plus h times x plus x squared divided by h. So at this point we can cancel h, and now we can replace h with 0. We can plug it in. So now we don't need to write the limit expression anymore. What we have left over is x plus 0 squared plus x plus 0 times x plus x squared. So now let's see what this is equivalent to. So x plus 0 squared is simply x squared. And then we have x plus 0, which is x, plus another x squared. X squared plus x squared plus x squared is 1 plus 1 plus 1 with an x squared attached to it. And that's going to be 3x squared, which matches with this function. So that's how you can use the limit process to differentiate x cubed. Now here's a question for you. Let's say if you want to calculate f prime of 2. What's the answer? So we know that we have to plug in 2 into x, into the derivative function. And it's going to be 3 times 2 squared. 2 squared is 4. 4 times 3 is 12. This is the slope of the tangent line, which represents the instantaneous rate of change of the function at x equals 2. But now, how can you use the limit process to get this answer? So if you want to get the slope of the tangent line, if you want to get the derivative as a number instead of as a function, what you want to do is you want to use this equation. F prime of a is equal to the limit as h approaches 0. Actually, I take that back. As x approaches a, it's different. And it's f of x minus f of a divided by x minus a. So f of x is simply the original function. In this case, a is 2. A is the number that we're plugging into the derivative function. F of x is x cubed. F of a, what is f of a? So to find f of a, notice that we don't have the apostrophe on it. To find f of a, plug in 2 into the original equation. So 2 to the third power is equal to 8. That's 2 times 2 times 2, 3 times. So we have x cubed minus 8 divided by x minus a. And a is 2. So it's going to be x minus 2. Now we need to prove that this limit is going to give us 12, because 12 is the answer. So let's see if we can get it. So what would you do to simplify this limit? X cubed minus 8. Notice that we can cube root x and 8. So this is the difference of cubes equation, which, as we mentioned before, it's a cubed minus b cubed. That's a minus b times a squared plus ab, don't forget to change the sign, plus b squared. So in this case, a is the same as x and b is 2. Because a cubed is x cubed, b cubed is 8. So the cube root of 8 is 2. So what we now have, using the equation, the limit as x approaches 2, it's going to be x minus 2 times a squared, which is x squared, plus ab, that's 2 times x, plus b squared, which is 2 squared, divided by x minus 2. So we can get rid of these two expressions. So at this point, we can now plug in the limit into the surviving equation. So let's replace x with 2. So it's going to be 2 squared plus 2 times 2 plus 4. 2 squared is 4. 2 times 2 is 4 plus another 4. 4 plus 4 plus 4, if you add it 3 times, is the same as multiplying 4 by 3, which is 12. And so we get the same answer. So that's how you can use limits to find the slope of the tangent line or to evaluate the derivative at a certain value of x. Now, let's work on a rational function. Let's say if f of x is 1 over x. What is the derivative of this function? So go ahead and find the answer using two methods, using the power rule and also using limits. So let's work with the power rule. If you have a rational function, first you want to rewrite it. 1 over x is the same as x raised to the minus 1. So now we're going to use the power rule. So we need to move this number to the front. So it's going to be negative 1 x, and then we need to subtract the negative 1 by 1. Negative 1 minus 1 is negative 2. And then let's rewrite it. we're going to bring x back to the bottom. Whenever you move x from the bottom to the top, the exponent, it changes sign. It went from positive 1 to negative 1. Now, if we bring x back to the bottom, the sign is going to change again from negative 2 to positive 2. So our final answer should be negative 1 divided by x squared. So now let's calculate the derivative using the limit equation. So let's write the original equation. F prime of x is the limit as h approaches 0 for the function f of x plus h minus f of x divided by h. So in this problem, f of x plus h is going to be 1 over x plus h. And this is going to be minus or subtracted by f of x, which is 1 over x divided by h. So here's the function that we now have. So we have a complex fraction. In a situation like this, what's the first thing that you think we should do? What I would do is I would try to clear away the fractions on top. To do that, I'm going to multiply the top and the bottom by the common denominator, which is x and x plus h. So if we distribute x times x plus h to both terms, what do you think we're going to get? So what's 1 over x plus h times x and x plus h? The x plus h will cancel, and we're just going to get x. Now what about 1 over x times x and x plus h? This time, x will cancel, and we'll be left with x plus h, but don't forget about the negative sign. So it's minus x plus h. Now we still have the limit expression. We have to keep rewriting it until we replace h with 0. On the bottom, do not distribute or FOIL. Leave it the way it is. If you distribute, you're going to make life harder, and it's going to be very difficult to solve this limit. So keep it like this. So now let's distribute the negative sign into x and x plus h. So it's going to be x minus h divided by everything that we have on the bottom. Notice what we can cancel in this expression. So we can get rid of the x's. X minus x is 0. So now what do we have left over? And what can we do next? So what we now have is the limit as h approaches 0, negative h on top, and on the bottom, h, x, and x plus h. So we can cancel h at this point. Once we can cancel that h in the bottom, now we can replace h with 0. So this is going to be negative 1 divided by x times x plus 0. X plus 0 is the same as x times x, which our final answer, x times x is x squared, so negative 1 over x squared is the derivative of the function. So we have the answer. Now what about this one? Let's say if f of x is equal to the square root of x. Find the derivative of f of x using both methods. Now the square root of x is the same as x raised to the 1/2. X is the same as x to the first power. And whenever you have a square root, there is an invisible 2, which is known as the index number. So this is the same as x raised to the 1/2. Now to find the derivative, we need to take the exponent and move it to the front. So it's going to be 1/2 x, and then we need to subtract the original exponent by 1. So what is 1/2 minus 1? 1 is the same as 2/2. 1/2 minus 2/2 is negative 1/2, because 1 minus 2 is negative 1. Once the denominators of the two fractions are the same, we can combine the numerators. So this is 1/2 x raised to the negative 1/2, which is the same as 1/2 x to the 1/2. So if you move the x from the top to the bottom, the negative sign will now become positive. And we know that x to the half is square root x. So if we have x to the half on the bottom, the final answer should be 1/2 root x. So let's see if we can get that answer using the limit process. So let's use the formula. F of x plus h is going to be the square root of x plus h. And then minus f of x, which is the original function. So that's simply root x divided by h. So how would you simplify a limit if you have radicals or square root functions? So this time, we don't want to multiply by the common denominator. Rather, we want to multiply the top and the bottom of the fraction by the conjugate of the radicals. So the conjugate is going to be radical x plus h, and we got to change the sign from negative to positive. So plus root x. And whatever you do to the bottom, you must also do to the top. So on the top, we're going to FOIL. On the bottom, we're just going to attach h to that stuff. So what we have is the limit as h approaches 0. On the bottom, it's simply going to be h times radical x plus h plus root x. On the top, we need to FOIL. What is radical x plus h times radical x plus h? The radicals will cancel, and you're simply going to get x plus h. If you're not sure about that last step, see it this way. What is the square root of 7 times the square root of 7? The answer is 7. The radicals cancel. If you multiply the inside, the square root of 7 times the square root of 7 is the square root of 49. And root 49 is 7. So you're just going to get what's inside. Now if we multiply radical x plus h times radical x, it's going to be radical x plus h times root x. You just simply write them together. And then root x times root x plus h is negative root x plus h. Don't forget about the negative sign. And then negative root x times positive root x. Root x times root x is simply x, but we have to carry along the negative on the outside, so it's negative x. Now notice that these two terms cancel. One is positive, the other is negative. Also, x and negative x cancel as well. So now what we have is the limit as h approaches 0. All we have is h on top and on the bottom times root x plus h plus root x. So now we can get rid of this h. And so at this point, we can replace the other h with 0. So the answer is going to be 1 divided by radical x plus 0 plus radical x. X plus 0 is simply x, so we have 1 over root x plus root x. 1x plus 1x is 2x. So 1 root x plus 1 root x is 2 root x. Because this part is the same, we can add the coefficients. 1 plus 1 is 2. So notice that we have our final answer, which is 1 over 2 root x. And somehow it got cut off, but you can always rewind the video and you can see that this is the correct answer. Now let's try another one. Let's say if f of x is equal to 1 divided by the square root of x. What is the derivative of this function? So let's rewrite it. This is 1 over x raised to the 1/2. Now if we move the x to the top, the exponent is going to become negative 1/2 instead of positive 1/2. Now let's use the power rule. So we're going to take the exponent, move it to the front. So it's negative 1/2 x, and then subtract the exponent by 1. Negative 1/2 minus 1 is the same as negative 1 over 2 minus 2 over 2. And negative 1 minus 2 is negative 3. So this is negative 3 over 2. Now, if we bring the x back to the bottom, this is going to be negative 1 over 2 x to the 3/2. And we can put it back in radical form if we write it like this: the square root of x to the 3rd. So our final answer is going to be negative 1 divided by 2 square root x cubed. So let's see if we can get that answer using limits. So we're going to have the limit as h approaches 0, f of x plus h, which is going to be 1 over the square root of x plus h, minus f of x, which is the original function, that's simply the square root of x, divided by h. So notice that we have radicals and we have fractions on top. So we need to combine the last two examples. To get rid of the fractions, we need to multiply top and bottom by the common denominator. To get rid of the radicals, we're going to have to use the conjugates. Personally, I think it's easier if you get rid of the fractions first and then multiply by the conjugate. So let's do it that way. Let's multiply the top and bottom by the common denominator. That is the square root of x plus h times the square root of x. So we're going to take this and distribute to both terms. So if we take radical x plus h times root x and multiply it by 1 over square root x plus h, what cancels and what remains? So radical x plus h will cancel, and radical x will remain on top. So let's put that here. And then it's minus. Now let's multiply 1 over root x times this stuff. Radical x will cancel, and the stuff that's left over is radical x plus h. Let's not forget to rewrite the limit expression. On the bottom, you don't need to distribute or anything. Just simply write what you have on the bottom. So we have h times radical x plus h times the square root of x. So now at this point, we need to multiply what we have by the conjugate. So let's move this to the top. So let's multiply the top part and the bottom part by the square root of x plus root x plus h. And let's see what's going to happen. So on the top, we're going to FOIL. Radical x times radical x is simply x. The square roots will cancel. And we seen earlier in this video why that's the case. Now we know that the two terms in the middle will cancel just like we did before. So root x times root x plus h will cancel with root x times negative root x plus h. You can write it out if you want, but in the end it's going to cancel. Now the last term, negative root x plus h times positive root x plus h, is simply x plus h with a negative sign in front. So this is what we're going to have after we cancel the two middle terms. On the bottom, simply write exactly what you see. Don't FOIL or distribute, leave it the way it is. Remember, if you FOIL or distribute the terms in the denominator, you will make it harder on yourself. So my recommendation, don't do it. Now let's look at the terms that we have on top. So once we distribute the negative sign, it's going to be negative x plus h. So let's rewrite that. I just realized I said plus h, but it's negative x minus h. We need to distribute the negative sign. So now x minus x will cancel. And so we're going to have negative h divided by what's on the bottom. After we cancel the x's, we can now cancel h as well. So the expression that we now have is the limit as h approaches 0, negative 1, negative h divided by h is negative 1, divided by everything on the bottom, which is the square root of x plus h, times the square root of x, times the square root of x plus the square root of x plus h. Now at this point, since we cancel that other h in the bottom, we can now do some substitution. So let's replace h with 0. So we don't have to write the limit anymore. So it's negative 1 divided by the square root of x plus 0 times radical x times square root x plus square root x plus 0. So now let's be careful at this point. So radical x plus 0 is simply radical x times another square root x. And on the inside of this parentheses, we have a square root x plus another square root x. So radical x times radical x, that's going to become x. Now the square root of x plus root x, what is that? So what is the square root of x plus radical x? This is 1 root x plus 1 root x, which is 1 plus 1 is 2. So on the inside we have 2 radical x. So we can leave the answer as negative 1 over 2 x root x. But I want to help you to see that these two are the same. So let's start with this one. Negative 1 over 2 square root x cubed. X cubed is basically x squared times x. Because x to the first power times x squared, 1 plus 2 is 3, we get x cubed. And the square root of x squared is simply x. So the answer is 2x radical x. So as you can see, these are all equivalent expressions, even though they look different. Now, let's say if you were to receive a multiple choice question on an exam, and it asks you to find the limit of this function. How would you do it? Now, granted, you can work it out. You can probably factor the numerator using difference of squares. And eventually you can cancel out h. But is there an easier way? Sometimes you might get an expression that looks like this, that might have natural logs, a trig function like sine and cosine, and you can't really find a limit using factoring techniques or multiplying the top and bottom by the conjugate or by the common denominator. In a situation like this, what you want to do to figure out the answer is you want to identify what the original function is. The original function is what we see here. It's x to the fourth. And then simply find the derivative of x to the fourth. The derivative of x to the fourth is 4x cubed. So remember, this function, this expression equals the derivative, so the answer is 4x cubed. So that's another way you can evaluate the limits, by working backwards. Now, let's say if you get a limit expression that looks like this. The limit as x approaches 4 for the square root of x minus root 4 divided by x minus 4. Now, for this expression, you can multiply top and bottom by the conjugate of the numerator, and that's going to work out. But if you realize that this equation comes from this expression, you can see that I have to fix it. This is supposed to be f of x minus f of a over x minus a. So you can see that the function is radical x. So if f of x is equal to the square root of x, you can use the power rule to find the derivative. Now, we've covered this example earlier in the video, and we said it's 1 over 2 root x. Once you have the derivative, you need to find f prime of a. So you got to plug in 4. So f prime of 4 is 1 over 2 root 4. And the square root of 4 is 2. So it's 1 over 2 times 2, which is 1 over 4. So this is the final answer. So you can multiply the top and bottom by the conjugate and get the answer this way, or you can identify f of x, find the derivative, plug in a, and get the answer. Either case, you want to be familiar with both techniques. But that is it for this video, so thanks for watching and have a great day.